Welcome everyone to VPod.ai. This deep dive is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyperconverged VMware, Hyper-V, Proximox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info.
Okay, let's unpack this then. Today, we're diving into something pretty fundamental, something your brain does constantly, juggling information, right in the moment.
Right. We often call it working memory.
Exactly.
Yeah.
But maybe thinking of it less like simple storage and more like the brain's active temporary workspace, what you're dealing with right now.
And it's crucial. I mean, you use it all the time without even thinking. Dialing a phone number someone just gave you.
Yep.
Or just following a sentence someone's saying, understanding it as it goes.
Or holding different bits of an idea when you're trying to solve a problem.
That's it. It's that mental scratchpad. You hold stuff there briefly, manipulate it. Right, the temporary buffer.
Yeah.
But here's where things get, well, really interesting. There's new research suggesting there might be a direct, like a visible signal of how well that scratchpad is actually working.
And it connects to something surprisingly simple.
Your eyes. Specifically, these tiny changes in how big your pupils get.
Yeah, it's kind of amazing. The idea that this involuntary physical thing, your pupils dilating, could actually give us a window into this core cognitive process.
Showing how efficiently you're handling that information, moment by moment. So our mission here is to explore this unexpected eye-brain connection. We want to understand what the research tells us about attention, learning, and maybe even just getting through the day.
All based on the material we've looked at.
Okay, so let's dig into working memory itself a bit more. We called it a mental scratch pad, but it's more active than just holding things for a few seconds, isn't it?
Oh, absolutely. It's not passive. It's about actively using the information. Think about that kitchen example. You're putting away dishes,
Yeah.
right? That's your focus.
Oh.
But you also need to keep that little note active in your head. We're low on dish soap. Working memory is handling both guiding the immediate task and holding on to that other piece.
So it's buffering things like phone number digits or processing words as we hear them.
Exactly. Or holding on to half-formed ideas while you're thinking something through. It's really dynamic.
And it underpins so much, like reading, math, making decisions.
Critical skills, yeah. But unlike your long-term memory, which is vast, working memory is, well, really limited.
How limited are we talking?
Typically, maybe 3 to 7 distinct pieces of information at once. And that stuff fades fast. Seconds, really.
Yeah.
Unless you consciously keep refreshing it.
Wow. Okay, so small differences in how well you use that limited space could really matter.
They can have a big impact on performance in all sorts of tasks.
And this capacity, it's not the same for everyone, right? The material mentioned things like genetics, sleep,
Stress levels, even just how focused you are right then, it varies quite a bit.
which must make studying it tricky, these internal fleeting processes.
And that's why this eye-brain link is so potentially powerful.
Right. So tell us about the research that found this connection.
Okay, this work comes out of the University of Texas at Arlington. From the CAM lab, that's the Cognitive and Attention Mechanisms lab, led by Matthew Robeson, an assistant professor of psychology, working with Lauren D. Garner, a doctoral student.
And what did they actually do in their study?
Well, they brought in 179 undergraduate volunteers,
Okay.
and they gave them these short, sharp memory challenges. Things like remembering specific colors or shapes or letters that flashed up on a screen very briefly.
Standard working memory tests, basically.
Pretty much.
Mm-hmm.
And the key part was, while the volunteers were doing these tasks, a very precise eye-tracking camera was recording the size of their pupils the whole time.
Okay, so tracking pupil size during these memory challenges, what was the big discovery?
This is the core finding. Pupil size wasn't just random or only reacting to the room light. It was actively changing, fluctuating, in sync with the mental effort people were putting into the memory task.
Ah, interesting.
And what was really striking was the link to performance. The participants who, well, scored lowest on the memory tests, they consistently showed less pupil dilation while they were doing
Like
their
dilation. So like their eyes were showing less effort and they performed worse.
That's how it looks, yeah.
Yeah.
Conversely, the participants who did really well, the top performers, their pupils showed larger dilation overall.
Okay.
But critically, it wasn't just bigger dilation, it was also more discerning. The dilation seemed more specifically tied to the moments when the important information needed grabbing and processing.
Wow. More discerning. What does that mean, practically?
It suggests that their attention system was better tuned, maybe. The pupil changes were more precisely aligned with the demands of the task.
Okay, I get that pupils react to light, obviously, and maybe surprise or something. But how does pupil size link up with mental effort, and specifically the accuracy of working memory?
So pupil size is controlled by the autonomic nervous system.
Hmm.
That's the same system managing your heart rate, digestion, the automatic stuff. And we've known for a while that pupils can get bigger when you're doing something mentally tough, like complex mental math. It reflects general cognitive load.
Okay.
But what this study seems to show is a more direct link. Not just general load, but linking those physical changes specifically, bigger and more precisely timed dilations, directly to how accurate someone's working memory was on that specific task.
So better recall correlated with these more pronounced and timely pupil changes.
Across the group, yes, sharper recall went hand in hand with those specific pupil dynamics.
That's quite something. So the eyes aren't just reacting to load, they might actually be broadcasting how well you're managing that load in your temporary workspace.
It fits nicely with this idea of resource allocation in the brain.
Resource allocation.
Yeah, the theory that when your brain decides something is important for the task at hand, it directs more energy, more attention, more resources to process it properly. The pupil dilation seems to mirror that surge of resources.
Oh.
So a weaker surge, like the lower performers showed with less dilation, might mean fewer resources got allocated effectively. And if fewer resources are applied, fewer details stick on that mental scratchpad.
Which leads to lower accuracy. Makes sense.
Exactly.
So this isn't just cool science, is it? It sounds like it could have real practical value. They mentioned using a non-invasive gaze sensor.
Absolutely. That's where the potential gets really exciting. Think about fields like, say, education or coaching, even clinical settings.
So?
Imagine using a simple eye tracker. They're getting cheaper and more common to get a real-time signal about someone's attention or cognitive load.
You could spot when someone's zoning out, or maybe when they're getting totally overwhelmed.
Potentially, yes,
Mm.
before it leads to mistakes or poor learning. You get this nonverbal cue about their internal state.
That could really change how support is given, couldn't it?
It really could. If an instructor or a therapist knows right then that someone's overloaded or maybe underengaged, they can adapt.
Like, slow down, explain something differently, suggest a quick break.
Precisely. Tailoring the help exactly when it's needed most to support that working memory function.
And there was that quote from Robeson, the lead researcher. He emphasized that the high performers didn't just show more intense focus, the bigger dilation, but also more sensitivity, better discernment in their recall.
Right. That combination seems really important. It adds this valuable piece to understanding why some people manage working memory better than others.
So it's not just raw capacity, maybe. It's also about how efficiently you allocate attention.
It seems strongly tied to that, yeah.
Yeah.
How effectively your brain focuses resources on what actually matters in that moment. And your pupils might just be showing us that efficiency level.
Now, this study was with undergrads, young adults. But if these patterns hold up, the future possibilities seem huge.
Definitely. The researchers themselves point out the need for more work, larger studies across different ages, different populations.
Like kids developing, or older adults, or people with cognitive disorders.
Exactly. We need to see if these pupil dynamics are consistent. But if they are, imagine the potential. Well, you could potentially use pupil tracking to help develop personalized learning plans for students.
Tailored to their actual cognitive load in real time.
Maybe. Or it could possibly aid in earlier identification of attention deficits. Or even help design better technology interfaces, ones that adapt if they sense the user is getting overloaded.
Wow. Adapting interfaces. That's pretty futuristic.
It is, but the groundwork is being laid.
Okay, so that's the future tech.
Right.
Very cool. But what about right now? For those of us without gaze sensors, are there things we can do to, keep our own mental scratch pad working well?
Yes, definitely. The material touched on some very practical strategies, and some are quite simple, kind of old school habits that really do help.
Like what sort of things?
Well, just taking brief pauses when you're doing something mentally demanding, like reading really dense text.
Just stop for a second.
Yeah. Let your working memory catch up, process, consolidate a bit before you pile more information on. Just manage the load.
Makes sense. What else?
Organizing information. Breaking things down into smaller chunks, like we naturally do with phone numbers, right? Splitting them into groups of 3 or 4 digits.
Yeah. Chunking. That directly tackles the limited capacity.
Exactly. Another thing mentioned is mindfulness exercises.
How does that help?
Well, they're known to train sustained attention. And there's some evidence suggesting that consistent practice might even slightly boost working memory capacity over time.
Interesting.
And don't forget simple physical activity, aerobic movement, like just going for a brisk walk.
Really? How does walking help my memory buffer?
It improves blood flow, including to the parts of the brain involved in executive functions, which manage working memory. Better blood flow, better brain function.
So it sounds like the basics still apply. Anything that's generally good for your brain health probably helps your working memory too.
That's pretty much the message. Good general habits support good cognitive function, including this critical temporary workspace.
Okay, so wrapping this all up, this research from UT Arlington seems to give us this really clear, measurable signal the way our pupils behave that links our subjective feeling of focus or effort.
To our actual objective performance on these crucial working memory tasks.
It's a pretty striking reminder, isn't it, that our eyes might be broadcasting more about what's going on inside our heads than we realize.
Especially the secrets of how we juggle all those small but vital bits of information that keep us functioning throughout the day.
Which leads to a final thought to maybe chew on. If our eyes can reveal something about our mental juggling capacity, what other seemingly simple physical signals might be out there broadcasting complex brain activity that we just haven't learned to read yet?
That is an intriguing question to ponder.
And before we go, we want to remind you about StoneFly's incredible offer, a 100 TB immutable and air-gapped SSO NAS for just $8,995. Find out more at StoneFly.com.